Hello students, welcome back to another class. I'm Jeffrey Odim. And today we are starting a very important topic, elements, compounds, and mixtures. This topic is quite broad, so I've divided it into 4 parts to make it easier for you to understand. In part 1, we'll focus on elements, what they are, examples, and how to classify them. In part 2, we'll explore compounds. In part 3, we'll look at mixtures. And finally, in part 4, we'll compare elements, compounds, and mixtures together with exam-style questions. So make sure you watch all 4 parts to fully understand this topic. And don't forget to subscribe so you don't miss the next video. First, let's define elements. An element is a pure substance that cannot be broken down into simpler substances by chemical means. I repeat, an element is a pure substance that cannot be broken down into simpler substances by chemical means. All the matter around us is made from elements. For example, hydrogen, oxygen, carbon, nitrogen, and iron. Atoms are particles of elements and are represented by chemical symbols. A chemical symbol is a sign, and it is made up of a letter or 2 letters to represent the atom of the element. Chemical symbols of atoms of elements are derived from the names of the elements. Abbreviations such as H, O, N, etc. are used to represent the elements. There are 109 known elements. Out of these, 90 occur naturally, while the rest are artificially made in the laboratory. Atoms. Recall, we said atoms are particles of elements. An atom is the smallest part of an element that can take part in a chemical reaction. It is the smallest part of an element that can exist and still possess the chemical properties of that element. Atoms consist of 3 particles called protons, neutrons, and electrons. The nucleus is made of protons and neutrons. The proton and neutron each have a mass of 1. Protons carry a positive charge while neutrons have no charge. The electrons are very light, negatively charged, and revolve around the nucleus in an orbital manner, in order to neutralize the positive charge in the nucleus. An atom is electrically neutral, because the number of electrons revolving around the nucleus is equal to the number of protons in the nucleus. So in summary, each individual element is made up of tiny, invisible particles called atoms. Every atom is composed of a nucleus and 1 or more electrons that revolve around it continuously. An element is a chemical substance consisting of atoms having the same number of protons in their nuclei. Therefore, the relationship between atoms and elements is that elements consist of specific kinds of atoms. That is, an atom is the base unit of an element. For example, oxygen is an element composed of atoms that have 8 protons and 8 electrons. Okay, let's explore the basic properties of the first 5 elements. Let's get started. Number 1. Hydrogen. Symbol H. Atomic number 1. Hydrogen is the lightest and most abundant element in the universe. It's a colorless, odorless gas, and it burns easily in air to form water when it reacts with oxygen. Hydrogen is used in fuel cells, rocket fuel, and ammonia production. Number 2. Helium. Symbol He. Atomic number 2. Helium is a noble gas, which means it's very stable and unreactive. It's lighter than air, making it perfect for balloons and airships. Helium is also used to cool superconducting magnets in MRI machines. Unlike hydrogen, helium does not burn or react easily with other elements. Number 3. Lithium. Symbol Li. Atomic number 3. Lithium is a soft, silvery metal and the lightest metal on Earth. It reacts quickly with water to release hydrogen gas. You'll find lithium in rechargeable batteries, medications, and lightweight alloys. Because it's highly reactive, it's stored under oil to keep it safe. Number 4. Beryllium. Symbol Be. Atomic number 4. Beryllium is a hard, grey metal that is strong yet lightweight. It's used in aerospace parts, satellites, and nuclear reactors due to its strength and heat resistance. However, beryllium can be toxic if inhaled or swallowed, so it's handled carefully. Number 5. Boron. Symbol B. Atomic number 5. Boron is a metalloid, meaning it has properties of both metals and nonmetals. It's found in borosilicate glass, fiberglass, and cleaning products. Boron also plays an important role in plant growth and natural processes. And there you have it, the first 5 elements of the periodic table: hydrogen, helium, lithium, beryllium, and boron. Each of them is unique, and together they form the foundation of everything around us. But we are just getting started. I would upload a video where we'll explore the properties of the first 20 elements in detail. So don't miss it. Make sure to like, subscribe, and turn on the notification bell so you'll be the first to watch when it's uploaded. Classification of elements. Elements are classified to organize them according to their properties, so that patterns can be seen and predicted. The classification is primarily based on 1. Atomic structure, number of protons, electrons, and arrangement in shells. 2. Physical properties, like state at room temperature, solid, liquid, gas, density, melting point, etc. 3. Chemical properties, like reactivity, ability to form compounds, type of bonds formed. But in this video, we will focus specifically on classification of elements into metals, metalloids, and nonmetals. I'll give a detailed explanation so it's easy to understand. Let's start from metals. Definition. Metals are elements that generally lose electrons to form positive ions, cations, and exhibit metallic properties. Location on the periodic table. Mostly on the left and center of the periodic table. Physical properties. 1. Shiny, metallic luster. 2. Good conductors of heat and electricity. 3. They are malleable, that is, they can be hammered into sheets. 4. Ductile, can be drawn into wires. 5. Usually solid at room temperature, except mercury. 6. High melting and boiling points. Chemical properties. 1. Tend to lose electrons in chemical reactions. 2. React with acids to produce hydrogen gas. 3. Form basic oxides, like NaO, CaO. Basic oxides are oxides that react with acids to form salts and water. They are typically oxides of metals, like sodium oxide, Na2O, or calcium oxide, CaO. These oxides are called basic because they can neutralize acids. Okay, let's move to nonmetals. Definition. Nonmetals are elements that generally gain or share electrons in chemical reactions and lack metallic properties. Location on the periodic table. Found on the right-hand side, except hydrogen. Let's move forward to the physical properties of nonmetals. 1. Dull appearance, not shiny, unlike metals. 2. Poor conductors of heat and electricity. 3. Brittle in solid form. 4. Can exist as solids, liquids, or gases at room temperature. Basically, the properties of nonmetals are the reverse properties of metals. Chemical properties. 1. Tend to gain or share electrons in reactions. 2. Form acidic or neutral oxides like carbon dioxide, a gas we breathe out and plants use for photosynthesis, and sulfur dioxide, a pollutant that can cause acid rain. 3. Reactivity varies. Halogens are highly reactive, noble gases are inert. Examples of nonmetals are oxygen, sulfur, chlorine, phosphorus. Okay, finally let's look at metalloids, semi-metals. Definition. Metalloids are elements that have properties of both metals and nonmetals. Location on the periodic table. Found along the stair-step line between metals and nonmetals. Physical properties of metalloids. 1. Can be shiny like metals. 2. Brittle like nonmetals. 3. Semiconductors. Conduct electricity better than nonmetals but not as well as metals. Chemical properties of metalloids. 1. Can behave like metals in some reactions and like nonmetals in others. 2. Form amphoteric oxides. Amphoteric oxides are metal oxides that can react with both acids and bases to form salts and water. In simpler terms, these oxides show dual, two-way, chemical behavior. They act like a base when reacting with acids, and like an acid when reacting with bases. Examples of metalloids are boron, silicon, arsenic, antimony. Before we end today's class, let's look at some basic terms, which includes atomic number, mass number, allotropes, and isotopes. Firstly, Let's explore the term atomic number and mass number. The atomic number is like an element's ID number. It's the number of protons in an atom's nucleus, which defines the element's identity. For example, hydrogen's atomic number is 1, and carbon's is 6. The atomic number of an element gives the element its characteristic, chemical properties, whereas the mass number is the total number of protons and neutrons in an atom's nucleus. It's like the atom's weight, for example. Carbon-12 has a mass number of 12, 6 protons plus 6 neutrons. Having said that, let's explore allotropes and isotopes. Allotropy and isotopy. Allotropy is the existence of one element in different forms, having different physical and chemical properties, like different shapes and structure. The different forms of the elements are known as allotropes. For example, carbon can exist as diamond, graphite, or graphene. These are all allotropes of carbon. They have different properties and uses, but they're all made up of carbon atoms. Think of it like different outfits for the same element. Examples of elements exhibiting allotropy include 1. Carbon, which can exist as diamond, graphite, graphene, fullerenes. 2. Phosphorus as white phosphorus, red phosphorus, black phosphorus. 3. Sulfur as rhombic sulfur, monoclinic sulfur. Isotopy. Isotopy, on the other hand, refers to the phenomenon where atoms of the same chemical element have different numbers of neutrons in their atomic nuclei, resulting in different atomic masses, but the same chemical properties, because the chemical properties of an element depends on the atomic number, and not the number of neutrons. This means that these atoms have the same number of protons, atomic number, but different mass numbers. In simpler terms, isotopy is when elements have the same atomic number but different mass numbers, like carbon-12 and carbon-14. They are called isotopes. Examples of elements exhibiting isotopy include 1. Carbon, which can exist as carbon-12, carbon-13, carbon-14. 2. Hydrogen, which can exist as protium, deuterium, tritium. 3. Oxygen, as oxygen-16, oxygen-17, oxygen-18. Great job, students! You've just completed part 1 of our series on elements, compounds, and mixtures. In part 2, we'll dive into compounds. You'll learn how elements combine to form new substances, and we'll look at some exciting examples from everyday life. So make sure you watch part 2 right after this, and if you haven't yet, subscribe so you don't miss the rest of the series. I'm Jeffrey Odim, and I'll see you in the next class, where we explore the world of compounds.